Hello and welcome to GM-BIST Construction. This is Benedict, your instructor. Today I'll be teaching you how to carry out your settings. I call this initial settings in your protastructure. How you begin, how you give your design a name. So we will be going to a new project, click on new project, and let us say settings, a project code. Our project code will say settings. So once you type your project code, the next thing you do, you choose your code, which one you want to use. You want to use your URET codes. In our tutorial today, class will be using our BS code, BS 8110, use of concrete. So we'll be using it. We now click on OK. So we are now in our project. We are now in our protastructure environment. So the next thing you do, at your top left, you see a setting center. Go to our setting center. Let's say project unit and format. So you have your unit, your SI unit here. As for British, we normally leave it in millimeters. You can actually change if you want to use meters, you change to meters. But what we adapt normally here is in millimeters, so we leave it in millimeters. So what I normally do is, for everything here, I leave it as default. Your label, you can decide to change your labels here. Your code. So the code you'll be using for your design for BS 81110. So these are the code you'll be using for your own design. So now I come to design of columns. I come to parameters, my rebars. You can actually do any type of settings here you want. So let me go to bin. Under my bin, I'll now be going to detailed drawings. Under detailed drawings, I'll go to steel, bars and links, and I'll check this so that I can have my details being represented this way. I can still go back to my slab. Under my slab, my rebar. So my maximum spacing for my slab, I want it to be 200. You can actually change your own to be 175, depending on what you want to achieve. And leave it to be 200. There's an appearance, show number of bars in level. I leave it this way. I go to my footings under general. Now maximum steel bar spacing, I leave it at 200. I leave it at 150. Show top bars inside the plan view. I want to check it. I want to check this too. So I'm not designing for pie. For pie, if you want circular pie, choose square pie, your pie size. So we can actually do some settings here. Your penetration, this one will actually be given to you for your soil test. They give your penetration and depth, which you go. But most of the times you see your penetration depth will be 75, and then your pie size, depending on specifying your design, your default pie length. But this one is 5 meters. That's one that can even go up to 12 meters, depending on your test. So all of this will be given to you during your soil test, and so you just factor it into your Prota software. So steel bar area step, all of this will be given to you. So these are mostly the settings you'll be able to carry out to your Prota software. You also go to your analysis. Under your analysis, go to your building analysis. The first thing you do is your pre-analysis. Under your pre-analysis, go to project parameter. Under your project parameter, you go to your foundation, your allowable stress of soil. This will also be given to you. It's so unfortunate that in our country here, most of the design we do it without our soil test. So you assume the value for your soil test. But what I normally advise a structural engineer is that always design for the worst case. So don't go and begin to use a higher or a good soil test or a soil value, your bearing capacity. Don't go and use a value that is high always go for the least. So what I normally do is I use 120 kilonewton per meter square. Even for my vertical subgrade coefficient, most of the times I go for the minimum one. I'll go for my lower limits. I choose this. So your natural loading. So if you have columns that are standing independently, so we have two types of columns, breast and breast column. So your breast columns are mostly columns are within walls, building between walls or having other supports enclosed. So on breast columns, there are columns that are standing on their own. So if you are designing isolated columns are just standing without walls at the surrounding, you can choose on breast column for no direction. So this is very important, because the software, if you not choose your breast column and you are going to design columns that are standing independently, your software will consider, because it's been programmed, it will now consider conditions for breast column, and it will design. At the end of the day, you may have a failure when you go to site. Although most of the columns we design this part of the world are breast columns. Then title, your project header. So let me say I'm designing for three suspended floors. So the design is made by, so let me say, engineer Ben. It's checked by engineer Joe. It's very important that you feed this information. So this is a project number 5 and date. So that's a 2025. So the reason why I say this is very important is that when you want to generate your calculation sheets, all these informations will appear on them. You don't need to go and begin to edit them one after the other. Once you feed them here, everything, all the informations you'll be generating within the analysis and the design you have carried out with, this will appear on it. So the next thing you do is to click OK. If you have made this change, intend to influence analysis result, yes. So the next thing you do is to edit your members. So for your column, click on rebar, it says select, select. So you choose the member size you want for your design. I want Y16 and Y20. I click OK. For my concrete wall, if I want to design my wall, maybe I'm having shear wall for either for my lift or to return a particular subcharge from the soil, I can choose Y12 for my design. So I will now go to concrete beam. I'll click on it, select and I'll select members. I'll choose Y16 and Y20. I'll click OK for my slab. So select members and I'll select. I'll click on Y12 for my slab. Then for my links, that's for my steel ropes, select and I'll select. I'll now click Y10. Okay. Now I'll go back to foundation. Under my foundation design, my rebar, I'll click select and I'll select members. I'll click Y16 and Y20. Click OK. Then links. We already selected our links, so we have Y10. This is OK for me. I'll click OK. So the next thing, I will now generate my loading. So under loading generator, click this. OK. Load case. OK. 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 Then I'll cancel. So I've actually carried out my settings. These are the most important settings you'll be able to do in your Protastructure. Do subscribe, like, comment and share our links to your friends so that they can also learn and be part of our design classes. I remain Benedict, your instructor from GM-BIST Construction. Thank you and do have a lovely day ahead. Bye.